So we're going to try to work on scientific notation here. The first problem, we're converting each of the following into proper scientific notation. I'm going to jump around and do the problems that are similar to each other. Okay, so to convert to scientific notation, the first thing we need to do is to convert into a coefficient that's between 1 and 10. So for our first problem here, to convert between 1 and 10, we're going to do 2.34 times 10. We have to see how many times we move the decimal. 1, 2, 3. We're moving it to the right, so it's actually going to be a negative 3. Alright, we're going to do our next one here. The same thing with a number less than 1. We need to convert to a coefficient that's between 1 and 10. So our coefficient is going to be 1.05 times 10. How many times we move the decimal? Just once. And to the right, so it's a negative 1. Come over here to number 7. Our coefficient is between 1 and 10, so it's 2.15 times 10. We're going to move our decimal 1, 2, 3, 4 times, and it's a negative 4 because we're moving to the right. Alright, and the last decimal here, 8.23 is our coefficient between 1 and 10, and our decimal is 1, 2, 3 times, negative 3. Alright, now for our positive numbers that are greater than 0, we're converting to a decimal between 1 and 10, so again it's going to be 2.714 times 10, and now we're moving our decimal 1, 2, 3 times to the left, so it's a positive 3. It should look like a 3. Number between 1 and 10, 9.86 times 10, and our decimal 1, 2, positive 2 because we're moving to the left. Here, our number between 1 and 10 is 2.046. Alright, make sure we keep the numbers after the decimal as well, times 10, and we have to move it 1, 2, 2 times to the left, positive 2. A number between 1 and 10 is 3.04277 times 10, and then 1, 2, 3, 4, 5 times. Alright. Here, our number between 1 and 10 is 6.4. But now, do we keep these numbers? We aren't going to keep these numbers because these are just placeholder zeros. So we'll strike through those. 6.4 times 10 to the 1, 2, 3, 4 times 10 to the 4. Okay. Make sure that we don't put those zeros in our scientific notation. They're not significant. They're just placeholders, so we did not include those in the scientific notation. Alright, and our last number, 2.07, that's already between 1 and 10. So we have 2.07 times 10. How many times do we need to move the decimal here? No times, so it's 10 to the 0. That'll actually become the same as 2.07 times 10 to the 1, or sorry, times 1. 10 to the 0 is equal to 1. Or 2.07. Right. That's it for this portion, and we'll start on the next. Alright, so our next section here, we're determining the number of significant figures in each of these problems. So again, I'm going to kind of chunk it out to ones that are similar. Alright, for our first one, 42,070,000. Alright, so again, like I said before, these last zeros here are placeholder zeros. Those are not significant figures. We're going to go ahead and cross those out so we can clearly see which one are significant. The 4207, those are significant figures. The 0 between the numbers, it's significant because it's between the numbers. So there's 4 significant figures here, these 4 right there. Alright, we're going to move on to another number where there's no decimals. 304, there's 1, 2, 3 here, the 0 between the numbers, that's significant, so we have 3 significant figures. Alright, our next one here is 6,002. Again, our zeros between the numbers, those are significant, our numbers are significant, so we have 4 significant figures. Alright, now for some other ones, we'll do ones that are only less than 1. Alright, so our 0.00788 here, these zeros in the front, they are locating the decimal. They are placeholders, or we'll refer to them as placeholders. So we only have 1, 2, 3 significant figures there, 3 significant figures. All right, for here, for 0.706, again, the first 0 is locating the decimal. That's not a significant figure, so the only significant figures are these last 3, 1, 2, 3, 3 significant figures, okay? We'll come over here, 0.00180, again, the first 3 are locating the decimal, not significant, so we only have 3 significant figures. Next one down here, the first 3 are locating the decimal. We'll get rid of those, cross those out. So we have 1, 2, 3, 4 significant figures. If anyone has any question as to why this last 0 is a significant figure, anytime we have a 0 all the way to the right, after the decimal, those are significant figures, okay? So this is a significant figure. I should have explained on this one back up here. This 0 is a significant figure because it's all the way to the right of the decimal. Again, the ones that are just to the left or right here, these are not significant because they're only locating the decimal. They're placeholders, okay? So here there's 4 significant figures. Here there's 3 significant figures because we are including the decimal all the way to the right, okay? And our last one here, we've got 0.000851. These first 4 zeros are locating the decimal, so only 851 are our significant figures. All right, and then another one along those same lines. Here we'll do the exponents, 2.9000. Again, because these zeros are all the way to the right and to the right of the decimal, these are significant. So we have 1, 2, 3, 4, 5 significant figures. They're all significant. 5 significant figures. The exponent doesn't tell how many significant figures there are. They tell us how many zeros they are, or locating the decimal. So the 10 to the third, that doesn't include any significant figures. It's only these initial numbers in our coefficient. So 5 significant figures, 4.1050. Again, those are all significant figures, especially the last 0 because it's 0 all the way to the right of the decimal. So here we have, 1, 2, 3, 4, 5. All right, we'll come over to this one. We have 1, 2, 3 significant figures. Again, the exponent is does not count any significant figures. That helps us locate placeholder zeros. In this case, there'll be 4 placeholder zeros, or actually we'll move it over 1, 2, 3, 4. There'll be 2 placeholder zeros. So that's not a significant figure. It's only the numbers in our coefficient. Okay, and now we'll just finish out the rest. Here we have 1, 2, 3, 4, 5. We include this last 0 here because that number is to the right of the decimal. Okay, so we have 5 there. We have 7.00. Again, zeros all the way to the right of the decimal are significant, so we have 3 significant figures here. 3 significant figures. And our last problem in this section, we've got 1, 2, 3, 4, 5, 6. All the numbers are significant. 6, okay? Hopefully you guys don't have any questions of those. There maybe should have been a few more like this first one here where we had more placeholder zeros. Just make sure that you're aware of the placeholder zeros. When you don't see a decimal and you see zeros at the end, those are placeholders. Those are not significant figures. All right. All right, our next section here, rounding each of the following to 3 significant figures. So the way we do this is because we're looking for only 3. We're going to start with the first numbers, first significant figure, and count in 3. So 1, 2, 3. 406 is our last significant figure that we're looking for. Then we look to the number after the significant figure, and either we round up or round down. Because 0 is less than 5, we're going to round down. So our 3 significant figures is 40.6. All right, 1, 2, 3 significant figures. All right, we'll do the same here for this one. Count in 1, 2, 3 significant figures. Our 0 is our last significant figure. We look to the number afterwards, which is a 7 here. 7 is greater than 5, so we're going to round up. So we're going to have 2.1 is our 3 significant figures. okay? All right, we'll come over here, 5,100,000, some other numbers. We're going to count in 1, 2, 3. The first 0 is our third significant figure. The one after that is less than 5, so we're going to round down. So it's going to be 510, and then we're going to fill in the rest of our zeros, 0, 0, 0, 0. All right, now the problem with this is, like I said above, when we have zeros all the way at the end and no decimal, these would normally be considered placeholder. So it looks like there's only 2 significant figures here. So to make sure that we represent this as 3 significant figures, we have to change it to scientific notation. So now we do our coefficient, 5.10. Now we've got 1, 2, 3 significant figures, and we need to figure out our exponent. So we count over 1, 2, 3, 4, 5, 6. Okay. All right. So this one here shows us 3. This one here, it looks like there's only 2 because all these look like placeholders. Okay. So in order to accurately represent that there's 3 significant figures, we need to convert it to scientific notation. Okay. So 1, 2, 3 here. It looks like these are only 2 significant figures. That's why we're doing scientific notation. All right, we'll come over here to number 28. 3 significant figures, so we count in 1, 2, 3. The 4 is our last significant figure, and we look to the number after that. It's exactly 5. All right. When it's exactly 5, we can round up sometimes, and we round down at others. And the rule for that is, when it's an even number, we round down, and when it's an odd number, we round up. Here, the 4 is even, so we have 3.04. We round it down, and then we need to make sure to include the rest, our placeholders. Here it's times 10 to the 21. So make sure that you include that, because otherwise you have some humongous number here with all sorts of zeros, and then you don't want it to convert it, so it's only 3.04. We need to make sure that we include all our exponent, okay, or all of our placeholder zeros like we did back here. All right, and the last one, we come over here. Again, these first zeros are only locating the decimal. They are not significant figures, okay? So we start with our first significant figures, the 9, 1, 3. Okay, 3 is our last significant figure, and the 5 is exactly 5, so sometimes we round up, sometimes we round down. So we're going to do this as either, first I'll do it in decimal form, and then I'll convert it to scientific notation. So we have our placeholder zeros, we've got our 9, 1, and then now we need to decide whether we round up or round down. Remember, sometimes you round up when it's an odd number, sometimes you round down when it's an even number. Here the 3 is an odd number, so now we round up. Okay, so we round up with our last digit. We've got 1, 2, 3 significant figures. And again, the rule for when we sometimes round up when it's exactly 5 and sometimes round down is it's odd. And the way I like to remember it is after we do that, round up, round down, you'll always end up with an even number as your last significant figure. Okay, so here we have 4, an even number. We had an odd, we rounded up to get an even number. Here we had an even number, we rounded down to end with an even number. All right, so hopefully that makes sense. Just remember the rule is when it's exactly 5, sometimes we round up. When it's an odd number, when it's an odd number, and sometimes we round down when it's an even number. All right, next section here. All right, so now we're moving on to our next section. We're calculating the answers. We want to make sure that we use the correct number of significant figures. All right, remember, for addition subtraction, the way we figure out the correct number of significant figures is the fewest decimals. We want to find the term with the fewest decimals. So let me do the addition and subtraction problems first. Actually, there's no subtraction problems, only addition. Or there is a subtraction. All right, so we're looking for the one with the fewest number of decimals. All right. First thing we do is we do our math. 24.7 minus 3 equals 3121.7. Okay, now we find the term with the least number of decimals. This one has 1, This one has none, so this is our term with the least number of decimals. So our answer should have no decimals. So this will be our last significant figure. We look to the number afterwards and decide whether to round up or round down. Here, because it's greater than 5, we round up. So this number is going to round up to 22. Okay, no decimals here, no decimals in our answer. All right, we're going to move on to our next one here. First, we need to do our math. Give me a second while I try to get a calculator. All right, so we have 0.77 plus 20.4 plus 11.2. All right, so our math here is 32.37. All right, so now we look for the term with the fewest number of decimals. We have 2 decimals here, 1 decimal here, 2 decimals there. So this is our term with the fewest number of decimals. We go to the 10th place. All right, so in our answer, the significant figures are going to go to the 10th place. This will be our last significant figure. We look to the number after our last significant figure to decide whether or not to round up or round down. So our answer is going to be 32.4 because we're rounding up because the 7 is greater than 5. So again, there's 1 decimal in the answer, 1 decimal in our term with the fewest number of decimals. All right, our last problem over here with addition and subtraction is number 34. We have 2.1 plus 5.07 plus 9.00155. Again, we do our math first, so it's 16.17155. That's what my handy calculator tells me. Now we look for our term with the fewest number of decimals. It's clearly not this one. We've got 2 here. We've got 1 here, so this is our term with the fewest number of decimals, just to the 10th place. So our answer over here is only going to go to the 10th place. All right, so this is our last significant figure. We look to the number afterwards to decide whether or not to round up and round down. Here we're going to round up, so 16.2 is our answer. All right, so make sure addition or subtraction, we're always looking for the term with the fewest number of decimals. Here we had none. Here we only had 1. Here we only had 1. So we have no decimals, no decimals, no decimals in the answer. 1 decimal here, 1 decimal in the answer. 1 decimal here, 1 decimal in our answer. Okay? So hopefully that's clear. All right, now we're doing multiplication and division. The rule changes a little bit. We're still looking for the fewest, but we're looking for the term with the fewest significant figures. Okay, so first things first, we do our math problem. 32 divided by 0.007. Sorry, 32 divided by 0.007. Okay, so the math says it's 4571.42857. Okay, all right, but we aren't going to keep all these numbers here. We only want the one with the fewest significant figures. All right, so 32.0, the 0 is after the decimal place, to the right of the decimal place. So there's 3 significant figures here, but these are placeholder zeros locating the decimal. We only have 1 significant figure there. So our answer is only going to have 1 significant figure. So we find our significant figure. Here it's 4. Look to the number after. It's something greater than 5. 7 is greater than 5. So we round up. So our answer is going to be 5, and then our placeholder zeros, 0, 0, 0. Okay? So only 1 significant figure here, 1 significant figure here, and make sure you don't forget your placeholders. All right? So think if you had earned $4,571 on your paycheck, and I told you I was just going to round up and give you an even number from rounding up your check, and then handed you $5, you would complain quite a bit. You'd want to make sure that you get your $5,000. Don't forget your placeholders. All right, our last math problem here. We've got 0.065 times 44.10 times 310. Make sure you always do your math problem first. It's 888.615. That's what my calculator tells me. Now we figure out which has the fewest significant figures. All right, we've got 310. that's two significant figures here. Okay, 0, 0, these are locating the decimal. Those are not significant figures, so we've got two significant figures here, and we've got 1, 2, 3, 4 significant figures here. Okay, that 0 is a significant figure. So we've got 2 and 2. Our answer should have two significant figures. We count in 1, 2 significant figures. This will be our last significant figure. We look to the number after. It's greater than 5, so we round up. So we got 8, 9, and then add in our placeholder 0. Okay? So 8, 9, that's our last significant figure. Two significant figures in our answer, two significant figures in our terms with the least number of significant figures. All right. Okay, so we're doing our last section here, convert each number into decimal form. We've got our number in scientific notation, and we're going to convert it into decimal form. What we need to do is move our decimal based on our exponent. Okay, when we have a -3, remember when we moved the decimal to the, it's the opposite of what we did before. When we move the decimal to the right, that would end up being a negative exponent. Okay, but now we're going the reverse. So now when we bring this down, the exponent down, we're actually going to move it to the left. All right, so we're going to move it to the left 3 times. So we're going to move 1, 2, 3, put our decimal there, and fill in zeros. All right, so there's 1, 2, 3 steps. Okay, so our answer is going to be 0.00621. Okay, make sure we include all of the numbers in our coefficient. All right, those are significant figures. All right, and for the next one, 4.27 times 10 to the third, we have 4.27. Okay, now we need to move the exponent 3 times. It's the opposite of when we go from the number to scientific notation form. So normally we're counting to the left. When we get a positive exponent, now we're counting to the right when we're converting the other way. So we're going to move our decimal to the right 3 times, 1, 2, 3 times, put our decimal there, fill in a 0, so we got 1, 2, 3 times. So our answer is going to be 4270. Okay, and that matches. There's 3 significant figures here. There's 3 significant figures there. The last 0 is just a placeholder. All right, so hopefully you guys don't have any questions about that last part. Just need to do a little thinking and make sure that we're moving in the right direction. Okay, so if we wanted to convert this back into scientific notation, we'd take our decimal, we'd move it 1, 2, 3 times. We're moving it to the left, so that's going to be a positive exponent. We moved it 3 times, and it's positive because we moved it that way. Back here, same thing. If we're converting from this number to scientific notation, we take our decimal, we're moving it to the right 3 times. If we move it to the right, it's a negative exponent. So I know that might be a little difficult to try to remember. Just remember when we go from the number to scientific notation, if you move it to the right, it's going to go be a negative number. If you move it to the